Now let's go beyond the existence of life itself, biology, and we imagine that microbes are the easiest forms of life to create, so they are going to be the most abundant in the universe. But of course, what's really interesting to us is companionship, and for that we have to talk about intelligence, and we understand that that's a tricky concept. And we start with our friends on the planet that we think of as further down the tree of life than us, and ask what's their intelligence. Well, we might think that birds are not that smart, but you may remember Alex the parrot, a famous subject of various psychological and behavioral experiments, was a talkative and playful bird. Parrots are famously smart, who actually came up with the concept of zero. We might imagine rodents like rats, who often display traits of being curious, have individual personality traits, they can anticipate sex, and actually reflect on their own thinking process, which is called metacognition. It's quite a high cognitive state. Well, let's go further away from humans and further down the food chain. This is a termite mound. You can see these all over Africa. Termite mounds are actually in detail, as the diagram on the upper right shows. They're engineering marvels. They're taller than our best skyscrapers scaled to the size of the organism, and in their construction, the termites have somehow used 5 different temperature control mechanisms underground to equalize the temperature in various cavities and chambers. All this without any grand-scale organization. All this from a creature whose brain is obviously very small. So the question is, what does the social insect behavior, which is often very complex, what does it actually imply about intelligence more generally? If you have intelligence that's in a distributed form, with a colony or a hive rather than the individual organism, how is that limiting, or how is that limited? How might it evolve? What's perhaps interesting about social insects is not whether or not they're smarter than us. I don't think they are. But on the Earth, evolution doesn't stand still. Humans and apes might only have certain time in the sun. Social insects have been here for hundreds of millions of years. And given hundreds of millions of years more evolution, what might they evolve into? And then you can go down to organisms that are truly tiny, bacterial forms of organisms, where you couldn't possibly imagine anything interesting or sophisticated happening there. And yet, bacteria have interesting behavior too. They utilize communal sensing of their environment, and they actually can do signaling, adaptive signaling. And some of their signaling, if you turn it into a bandwidth, has about the same bandwidth as a telephone conversation a human might have. So they cooperate in a commensal way with other microbial species. And they're advanced biochemical factories. There are different types of bacteria that can sense magnetic fields, and in the example on the lower right, there are actually bacteria that can create nanowires or even synthesize gold and use it in their metabolism. So we should be careful before we diss microbes as not being sophisticated enough to even enter the realm of a discussion of intelligence. Now we know that we're smarter than rodents, at least.
Experiment 2. The food is connected to a mild electrical current. The hamster has learned a valuable lesson. Beware the hand of man. Wise guy, eh? Ow! 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 Hamster 2.
What about crows? We know that corvid's family is incredibly smart for its size. That brain is a very efficient neurochemical package, and we can get an example of that here.
Crows have become highly skilled at making a living in these new urban environments. In this Japanese city, they have devised a way of eating a food that normally they can't manage. Dropping a nut from a great height onto a hard road does sometimes crack it, but some nuts are particularly tough. So the crows have devised a better way. drop it among the traffic. The problem now is collecting the bits without getting run over. So some birds have refined their technique. They station themselves beside pedestrian crossings. Wait for the lights to stop the traffic. Then collect your cracked nut in safety.
I think after seeing that, you might hesitate before using the phrase bird-brained again. So how smart are we? Well, obviously we're the top dogs or the alphas of the planet. But if you look at this ratio or plot of body mass against brain mass for primates, mammals, and birds, you'll see that humans are not off scale. They're definitely the high end of brain mass per body weight. But we neither have the biggest brains on the planet, we're not the highest in this graph, nor do we have completely exceptional ratios of brain mass to body mass. So it's a continuum, and we have to be careful how we define intelligence. What is it that really matters about intelligence? Here's a perfect example of how you have to take a bigger picture view. On the top left, you see the evolution of brain size of humans, showing the crescendo going to the present day on the left side of the diagram, where in two vaulting stages, the brains of pre-humans 2 and 1 million years ago doubled and then trebled in size to present brain capacity. And the last brain advances happened fairly recently, in the last few 100,000 years. On the right, you see a plot based on measuring the skull casings of dolphins and toothed whales, the ancestors of present-day dolphins and whales, going back 50 million years vertically. And you see the mean brain to body mass ratio, shown by those lines, that's the mean. And you can see how the body to brain mass ratio has increased, bigger brains, as dolphins and toothed whales have evolved. And that's the red line and then the green line. The black line shows how our ape ancestors evolved. And you can see that the vaulting of our intelligence to the top right of the diagram happens fairly recently. But for most of the last 50 million years, the largest brains were creatures who lived in the oceans. The ape's progress is very recent. So if aliens had visited the Earth over most of that 50 million years, they would find the Earth's smartest creatures in the oceans. They would not have been our ancestors. We can wonder what goes on in the brains of marine mammals, creatures that I'm pretty sure are smart, dolphins and orcas and so on. I don't really think they have abstract reasoning. I'm not sure if they are sentient at the level of understanding their existence and then non-existence. Elephants are apparently aware of non-existence. So we do share the planet with creatures who have sentience at a high level. So humans are just not that exceptional in every aspect. Here's another example of how we have to keep intelligence in context. Cephalopods are like the aliens among us. They separated from us on the tree of life about 400 million years ago. They're solitary creatures. They don't show social behavior, so understanding their intelligence based on behavior is very indirect. It's the best we can do. They're creatures with 8 brains, 1 in each of their arms, So their whole central nervous system and brain function is distributed differently than ours. Their skin is their sensor. They have 100 million chromatophores, or small sacs filled with varying dyes that, as you can see in this example, can change not only to match the color, but also the texture of almost everything in their environment, from the sponge here to the sea floor to a rock. Extraordinary ability that they can do in about 1/10 of a second. We think they are smart. We think they are clever, but we really don't know how to understand them, and we don't know how to communicate with them. So what would the alien intelligence be like if this is an alien intelligence on our own planet? We also have to consider the possibility of evolution beyond our state. We're approaching a point with our technology where we can start to replace our organs and some of our capabilities with machine parts. That's taking us towards a cyborg type of future. It sounds futuristic, perhaps dystopic, the subject of a lot of science fiction, obviously, but it's happening all around us. And so, taking the big view of human history, it's possible that evolution will have a post-biological phase, when creatures develop machine intelligence or computational forms of intelligence, and so transcend their biological limitations. And we may be approaching that barrier. Here's an evocation of that from the masterful film director Ridley Scott in the penultimate scene from Blade Runner.
I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched sea beams glitter in the dark near the 10-house gate. All those moments will be lost in time, like tears in rain. Time to die.
As I'm sure you know, that film was made from the masterful story by Philip K. Dick, When Androids Dream of Electric Sheep. It envisages a future when humans have created cyborgs with masterful levels of intelligence and extreme physical capabilities to do our bidding, to do our dirty work. In a sense, we're already doing this. The cyborgs, the androids, would do our dirty work. They will be extensions of us, traveling through the solar system, gaining us wealth, doing our industrial activity. In the film and the book, they had kill switches and were given limitations on their sentience and intelligence. But at some level, they were indistinguishable from humans. Is this what our future is? We don't know. Has this played out elsewhere in the universe? We don't know. But it's a fascinating question. That's the end of this topic.